We don't have to derive it first, right?
No. Okay, so differential equations are the equations that are derivatives. Okay, so that should make sense. A differential equation is a function that is a derivative. So what we're going to do is we're going to take the differentiated function, and now we're going to go backwards and find the original function. Okay, so I don't know if you need to write down the definition of what a differential equation is, because it's what I just told you. But if you want that in your notes, you can write it down. Maybe something like it has a dy dx in it usually. Okay, or it might have a dy like that, prime. However. Okay, so this is kind of what I think is very helpful. This actually comes out of our AP Calculus textbook. And what it is it's your procedures for how to solve a differential equation. Okay, so if you can remember these procedures, which I would highly recommend you write down, you should be okay. Okay, so your first step, they might write the derivative as y prime. So your very first step might be to rewrite that as dy dx. Okay, so that's going to be a step that you may or may not have to do depending on what is given. Okay, the second step is that you're going to multiply both sides of the equation by dx. And that will probably be a necessary thing for you to do. I haven't seen one where it wasn't necessary, so I'm not sure why it says if necessary. Okay, then your third step is that you want to separate your variables, meaning if we're working with x's and y's, we want all of the x's to be on one side of the equation and all of the y's to be on the other. So my dx is with all the x's and my dy is with all the y's. Okay, once you have your separation of variables, your fourth step is to integrate. So you're going to undo the derivative. Okay, hopefully you remember that you're adding 1 to the exponent and dividing by it. Okay, you're going to add c to one of the sides. We're going to keep that on the side that has the x in it because our last step is going to be to solve for y. So we're just going to put that on the x side. Okay, and your last step there is going to be to solve for y. The sixth one will be dependent upon what is given to you. If they give you an initial condition, such as a point, we'll be able to find the exact equation. If they don't give it to us, then we'll have what's called a general solution, which involves a c. So I'll kind of talk about that scenario a little bit more here. Okay, we good?
No.
Good now? All right. So, example. Okay, so our very first example, it asks us to find a general solution. Okay, so this means that they're not giving us an initial point, okay, an initial condition. So our equation should be in terms of c, or not in terms of c, but it will have a plus c at the end. Okay. All right, so looking down your little procedures, what is the very first thing that you should do? Okay, so the very first thing you wrote down wasn't necessary because it's already in terms of dy dx. So the first thing that we're going to do is we're going to multiply both sides by dx. Okay, so I'm going to kind of write this up here. It's not really showing my work very well, but it'll work. Okay, so if I multiply the left side by dx, what's left over? dy. Okay, and then on the right side, I would have negative 3 over x to the 5th dx. Okay, what's my next step after this? Separate the variables. So do I have all of my y's on one side and all of my x's on the other side? Okay, so I'm good to go here. By the way, it kind of is confusing by what's in front of the dy. What's the invisible value that's in front of the y? A 1. So I'm going to put a 1 there just so it's kind of a placeholder. It's going to help our brains to integrate because our very next step is now to integrate both sides. Okay, so if I integrate the value of 1 in terms of y, what does that become? Okay, so remember you're adding a y. So y. And you're right, I would say plus c, but I'm going to save the plus c and only do it on the right side, the side with the x. Okay, so let's say I was going to integrate 5. What's the integral of 5? 5x or whatever variable we're integrating it. 5x plus c, right? Yeah.
Wait,
Okay.
so how do you do this one?
So you're adding. Well, yeah. Then it would be 2y. The integral of dy equals y. The integral. No. dy does not equal y. The integral of dy equals y. Yeah. Integral of dy equals y. You said dy equals y. Those are two different. Okay. Fair game. Okay. Can you integrate the right side? What is the integral of negative 3 over x to the 5th? Okay, so maybe.
Half x.
Okay, so do you remember that I pull this up, right? So it's the same as negative 3x to the negative 5th power. And we're adding 1, Chaz. What's in front of you, Chaz?
My worksheet.
Look up. Okay, if I add 1 to negative 5, what number do I get?
Negative 4.
Okay, so I'm going to have negative 3 x to the negative 4th. Probably would have if I would have warned you first. Plus
I got
c.
negative 5 plus 1 on lockdown.
Why isn't dx x?
What?
Why isn't the inside derivative of dx x? It's the dy as well.
1 dy.
You're still multiplying by 1 dx. But that's attached to the stuff.
Yeah. So like I'm not integrating two separate terms. There's only one term on both sides that I'm integrating, not two. Okay, so simplify that. If I have a negative 3 over negative 4, what happens? 3/4. And if I have a negative exponent, what happens?
Goes to the bottom.
It does. So I'm going to have 3 over 4x to the 4th plus c. And that would be my general solution. Okay, so all I really know about this function is that it's like, I don't know, what does that look like? A volcano? But a plus c could potentially take this function and move it up and down. So therefore it's a general solution. Does that make sense by what I'm saying? Okay, let's try another one. Whoa. Okay, first step on this one. Multiply by dx. So what does my left-hand side become? dy, or, yep, you can call it 1. I feel like 1 makes more sense to my brain. Then I have negative 1. Do you feel like you want to pull that x to the third upstairs for integration?
Yeah.
So x to the negative 3 dx. Okay. Are all of my variables on the correct side? Doing good so far. So far we haven't had too complicated of questions. So now what do I do? Good. Anti-differentiate.
Bless you.
So what does the antiderivative of 1 dy? Y. And the antiderivative of negative 1x to the negative third? Huh? Ooh, can I go ahead and jump on this? Sorry, did you guys follow that? I don't know why I could do the negative and not. Did you guys follow that? And then I just get rid of the negatives? Okay, plus C. Doing okay? We need a harder one.
Yeah.
Do you want to do this trig one? I haven't seen really hard ones yet.
Why?
Why do you guys not like trig? Trig is not that hard.
Okay. That's not the reason.
Look at the word.
The reason trig is so hard is because
the
There's
word.
so many rules.
you were
Because there's
gone last
where?
year when you taught it to us, so that's why I don't understand the unit circle.
Oh.
Mr. Devers taught it to us.
Oh, that's right.
Not that he was bad,
Interesting.
but you know, I still don't understand.
Well, we can go back and review that if you guys
Yeah.
want.
It's okay.
We could spend a little extra time reviewing trig.
Oh,
Is it necessary for the rest of the year?
No, but it's necessary for AP Calcs kids.
Necessary
Sorry,
for the rest of your
buddies.
life.
Sorry, buddies. All right, first step on this one.
Multiply by dx.
Multiply by dx. So we end up with dy equals the cosine of x dx. Okay, so if you want to throw a 1 out in front of there, it makes your brain maybe a little bit easier to work with. So now what do we do? Now what do we do?
Derive.
Integrate. Antiderive. Derivative of 1 dy.
Freshman, last names C through F. Please report to room 126 now. Again, that's last names C through F.
Good. Okay, so the antiderivative of cosine is negative sine, very good, of x plus c. That was not so hard.
I think we need to make a school rule that the sophomores need to park in the back.
Yeah.
Wow, that's
So I
not
had to
very
park across the
direct.
street today. There was no more spots in the front parking
Oh,
lot.
that is a bummer.
When they do the renovation, where they change the
Early.
do we have enough property to do that?
Oh, I don't
What
know.
about the park?
You guys are asking the wrong person.
Yeah, get rid of the football field.
Okay.
Y'all can
Make us practice. Yeah, exactly. They have a nice enough field.
All right, let's finish this up and then we'll talk about that later. Focus.
I'm the middle school.
Okay, last one I'm going to do for you on your general solutions.
No, they have to.
Okay. Okay, let's finish this. We got 10 minutes.
No, it's at 9:30.
Oh, we'll take a worksheet with you.
I'm sorry.
All right, so I'm going to multiply by dx. So you get dy equals negative 1 over x plus 2. Let's see if you remember this rule. This is one we just learned not too long ago. Okay, you can throw the 1 in front. So now what's my next step? Integrate. Heidi-ho is only for deriving, so it's not that rule.
I have no idea.
Okay, what's the integral of 1 dy? Y. Okay. What is the integral of negative 1 over x plus 2? What happens when you have a quantity down there?
Bring it up and
Okay, do we have, where's our little sheets? Didn't I have you write down the rules? Remember that? This thing right here?
natural law.
Okay, yeah, it's a natural log rule. So do you see that rule number 9? Okay, so when we have a u, and this one's not written in terms of u, but basically what happens is the rule that we're going to use, let me write it over here. Okay, so if we have, let's call it the integral of 1 over No, how do we want to write this? It's actually u prime over u du equals the natural log of the absolute value of u.
So that equals the natural log of 1 over x plus 2.
Mm-hmm. So, okay, so you remember when we talked about the hook-on factor? Have I used that word in this class? Hook-on? Or the stuff. I've been using the stuff, the extra stuff, right? Okay, so with this rule, the derivative of the inside goes into the top, which is actually being multiplied. Okay? So, Chaz,
Yeah.
the bottom piece would be my u. Okay, so what is my u value?
Why is the bottom?
The bottom one.
Why is it the whole thing?
X plus
Because
2.
that's the rule. Okay, so the x plus 2. So that means the top would have to be the derivative of that. So what is the derivative of x plus 2? 1. Is 1 the same as the top?
Yes.
No.
Not exactly, right? So what I would have to do is I have to like undo it. Okay, so how can I turn a negative 1 into a 1?
Times it by negative 1.
Multiply by negative 1. So what I have to do is if I multiply by negative 1, I also have to divide by negative 1. Okay? But the divide by negative 1 goes out in the front.
What other two is not making any sense?
Okay? Because now this top piece is going to turn into a 1.
So this is U substitution.
Yeah, it kind of came from U substitution.
I'm like reviewing this.
It's also can be like a reverse chain.
I'm so confused right now.
Okay, so write this rule down. We'll do another one and I'll show it to you again. Write that rule down on your little cheat sheet of all your rules. Cheat sheet of the rules. Okay, so do you see how now that I've rewritten this? Okay, the bottom piece is my u, right? So my u is x plus 1. And the derivative of this is 1, which is the top. So this is set up into this notation. So now when I integrate it, it's just going to be the natural log of my u. What is my u again?
X plus 2.
X plus 2. So what is the integral here?
Pick the right side.
Okay, we have a negative, and it's just going to be negative natural log of the absolute value of x plus 2.
But why do you have to multiply? Why do you have to multiply it by negative 1?
You guys need another one of those?
Well, like, I
Less
understand how you
than
can't just. Why can't we just jump?
Why
Why
what?
do we have to do all the red work? Why can't we just know
Yeah,
what the
it's like the
bottom
You can. I was just trying to explain it.
A fraction of degree separation between.
Yeah, because the derivative.
Positive, but if it's negative, it's negative.
Yeah, well, because you have to look at the derivative of the bottom. So see how the bottom is x plus 2? So the derivative of x plus 2 is positive 1. But I have a negative up there,
Or
so
positive.
yeah.
If it's a negative or a negative, it's a positive.
Okay.
Yeah.
Yeah.
Oh my god.
Okay. Let's do another one, and we'll do another one of those natural log rules here, just so you can see another one.
Which comes?
Shoot. Okay. So, number 5, are you with me? So now it says find a particular solution. So what is different in this section than the ones that we just did? Okay, we have a point, so we're going to be able to get a specific exact equation that the original function is. Okay, so I'm going to ignore this point. This is a point, it's an ordered pair. I'm going to ignore that for now. That's going to be my very last step, and that will help me find my C value. Okay, so what's my first step on finding the original equation? Multiply by dx. Okay, so I have dy equals, and then how do you guys feel about pulling the x squared up? So that would just be x squared to the negative 2 dx. Everybody okay there? Really lost you guys on that natural log one, huh?
Yeah.
X.
Everybody good? Okay, now what do I do?
Y.
Anti-differentiate. Okay, so I integrate. So integral of 1 is y. And what is the integral of negative x to the negative 2? Okay. So you get, okay, I'll write this out. I did hear Joe just jumped right to it, over negative 1, right? Which is the same as just 1 over x plus c. Because the negatives cancel, right? Negative 1s. Or are you stuck on why it's that?
Yeah.
So, okay, so if I'm just adding 1 to my exponent, negative 2 plus 1 is negative 1.
Oh.
Negative 1 divided by negative 1?
Yeah.
Okay, so my general solution is 1 over x plus c. So now what I'm going to do is I'm going to take the ordered pair that is given to me, which, by the way, which one is my x and which one is my y?
Your y is 7.
Good. So my x is going to be 3 and my y is 7/3. All I'm going to do is plug those in now and I can solve for the c and then rewrite my exact solution. It's just saying y of, that's just the equation. Like instead of f of x, it's using y. Just for funsies, I guess. I don't know. I know.
So basically we just find the c.
Okay, so if I was going to solve for c, what would you do? Subtract 1/3, so what's 7/3 minus 1/3? 6/3, which is 2. So now, what is my particular solution? Plus 2. How do we do on that one?
Why don't we plug in this?
Because you want it to be an equation, not a number. If I plug in the x into my very ending piece, then I have a function. I have a number, not a function. Okay, do you want to do another easy one like that? Or do you want to do a harder
I
one?
think we should do some from the homework page.
You want to do a couple from the homework page?
Yeah.
Ooh. Hold on, let's do this one down here real quick, because this is one where we have to, okay, put one of these in your notes, because this one down here requires us to separate variables, because we haven't had a separation of variables yet. So let's do this one example, and then we'll do some off the homework. Okay, so this is the first time where we've had an x and a y on the same side. Okay, so what is the first step that we've been doing the whole time?
On both sides by dx.
Good. Okay, so that gives me dy equals x over y squared dx. Okay, so now you see that I have an x and a y on that right side. I want all of my y's to be on the same side, so I need that y squared to get to the left side. So how am I going to get it there? By multiplying it, because it's in the bottom, right?
I brought it up to you.
Oh, you just said the wrong word. That's okay. Okay, so now once my variables are separated, now what do I do?
There's literally no numbers in that equation.
There's a
There's
2.
a 2.
Okay.
Is there?
Okay, so now I'm going to do the integral. So I'm going to integrate both sides. Okay, what is the integral of y squared? Y cubed over 3, or 1/3 y cubed, however you want to say that. Okay, what is the integral of x? X squared over 2, or I'm going to say 1/2 x squared plus c. Right, because this time we have a number in a different value than 1. Okay, now I have to solve for y, because this time it's not just y equals. So how are you going to isolate your y here?
Times everything by 3.
Very good. We'll multiply everything by 3. Now check this out. Watch what happens here. I'm going to have y cubed. 3 times 1/2 makes
3 halves.
3 halves x squared. And what happens if I multiply 3 times c?
You get 3 c's.
You would think so. But it's just c. Okay, now think about what the value of c is trying to represent. C is representing some constant number. Okay, it's not 3 times a constant number, it's just a constant number of any kind. Okay, so this kind of is one time that you like ignore the rules of algebra, and instead of multiplying 3 by a number, we're just going to call it, hey, it's still a constant. So we get to be a little lazy there. Okay, oops, I forgot my swear. Okay, now what do I do to get rid of the cube? Good. That is the answer. Does that one make sense, or do I need, not on this one? You might have one where you'll have to do that though. Do I need to do another example with that separation of variables idea?
Oh, man.
Let's just go.
Let's do some from the homework that have that.
Okay, let's get the homework out. Okay, where do you guys want to start? Do you want to start with a tougher one? Number 3? Yeah, you guys have like 40 minutes. Lots of time.
In theory, we have enough time. But
So you want to start with number 3? Alright, what's the first step? Multiply by dx. So we get 1 dy equals, ooh, this is a good one to do right off the bat. See if you recognize it. Okay, are my variables separated? Yep, so what do I do next? Antiderive, integrate. Okay, what is the integral of 1 dy? Y. What is the integral of -2 over x? Nice, good. So remember when it's just the plain old x in the bottom, that's your natural log rule. Okay, so it's -2. Okay, so the -2 is kind of like a constant. It's going to get thrown into the front. Your u is your x, your bottom piece, plus c. Don't forget the absolute value. That is necessary because it's impossible to have a natural log of a negative value. That is needed. Everybody okay on that one? That one was less yucky. So number 4 is like almost exactly the same. Number 6 is going to be that rule, that same rule that I showed you before. It's easy though. Number 9? Okay, yeah, good idea. Number 9. Okay, first step on number 9. Multiply by dx. So I get dy equals -3 plus x squared dx. Okay, oops, over y squared. My bad. Okay, so gotta separate variables here, so I need that d or that y on the same side as my dy. Good. Multiply it over. Perfect. Okay, now what do I do? Integrate it. And technically, notation-wise, I should put that quantity that's in front of the dx in parentheses, because when I integrate it, I'm integrating it as a whole piece, like each term individually, but the whole thing is getting integrated. So, what is the integral of y squared? Good. 1/3 y cubed. What is the integral of -3? Good. -3x. And the integral of x squared? 1/3 x squared. And we throw a plus c.
X cubed.
Cubed. Ooh, thank you very much. Good catch. Cubed. Okay, now how would you isolate your y? Multiply everything by 3. So I'm going to have y cubed equals -9x plus, what's 1/3 times 3? And then notice I have a c at the end, so this is the only letter that you don't have to multiply things by in calculus. And then what's my last step here? Cube root. I'm going to put my terms on the inside in order correctly, just so it matches my answer key. So I'm going to always do x cubed minus 9x plus c all on the inside. Now, can I reduce that at all? Can I take the cube root of x cubed? No, good. If it was just straight up the cube root of only x, then I could, but not when there's adding or subtracting going on of any kind. E, remember, E is a number. No. 2.718. I used to know more, but I can't remember it right now. You want to do E? Or 10? Okay. What's your first step?
Trying to find dx.
You guys are really good at that first step. So we have dy equals e to the x over y squared dx. Okay. Get my variables on the same side, so what do you do? Multiply by y squared. So y squared dy equals e to the x dx. Okay, then what? Integrate. Okay, integral of y squared.
1/3 y to the cube.
Nice. Whoops, I wrote an x. Let's try y. Ooh, do you know the integral of e to the x? E to the x, very good. It's its own derivative in its own integral.
Now we always multiply by.
Multiply by 3? Yeah, it's kind of weird that it landed that way. So we're going to have y cubed equals 3 e to the x plus c, and then your last step? Good. So that one wasn't too bad, although it looked way grosser. Number 5?
There's a freaking bag.
Yeah, the backside is your particular solution. So the only difference is then you have to find C on the back. They'll give you an ordered pair.
We do.
5 integral of cosine is just negative sum.
Okay, let's do 16.
Should we do one of the particular ones? Yeah, let's do a hard one. What do we got? Backside 16. Ooh. Ew. I'm gonna guess this is gonna play out really nice though. Wow, okay. So first step, we're going to multiply by dx, right? This one is actually quite tricky. We'll see if you guys can follow this one. So we have dy equals e to the x minus y dx, right? Sorry, that's an x. Okay, everybody watching this? This is tricky. Chaz and Travis? This is a tricky one. So, do you notice I have an x and y up in the exponent? How am I going to separate those so that I can get the y to the other side? Do you know any exponential rules? What happens when you subtract exponents? What is that like? When have we ever subtracted exponents?
The negative exponent becomes positive exponent. Like when it's like x to the negative third times x to the sixth.
Oh, I see what you're saying. Okay, so you had like x to the, what did you say?
I don't know, just use any number.
Okay, to the negative 2 times x to the negative third. You have the right idea here, because what happens when you're doing that scenario? If you're multiplying those, you end up adding exponents, right? So negative 2 plus negative 3, right? So so what I'm going to do is I'm going to separate this and rewrite it. Okay, so watch what I do here. This is going to be e to the x times e to the negative y. Did you catch that step? Travis, you missed it. That was really exciting.
See, the thing about that is I really
You what?
I highly doubt it was exciting.
Oh,
And it might have been like, wow,
maybe. Maybe it was exciting.
enlightening.
Enlightening.
I don't think
Okay.
it was- I don't think it would have excited people.
Okay.
Okay, so how do I get to the e to the y to the other side? Divide. So I'm going to divide by e to the negative y. And if you divide by, let's call this 1 over e to the negative y, what would that be the same as on that left-hand side? If I have e to the negative y, I could pull it up, making it positive, right? So this would really be the same as e to the y dy equals e to the x dx. That's pretty fancy. So now, my next step is I integrate it. Okay, what is the integral of e to the x? Or, yeah, sorry, e to the y. E to the y. And what is the integral of e to the x? E to the x plus c. This is a good one, huh?
Wait. You just put it in the bottom,
Hmm?
and then
What do you mean put it in the bottom?
because no, you can't. Wait, you could do e over negative. Wait, y to this.
Oh, a bummer, my work over there is gone. So, does anybody know how you get rid of an e? What things cancel an e? What's like the opposite of an e? A natural log. So what we're going to do is we're going to natural log both sides. So we're going to throw a natural log in front of both these sides. And then what happens here is you have to understand your properties in order to do this. Do you guys remember that when I have a natural log with an exponent, what happens with it? So like this exponent right here, this y, so it's the power property and it just goes into the front of it. Same thing on that one. So I'm going to end up with y, and then what's the natural log of e? One. The natural log of e is 1, so it goes away, so I have like 1y. And then same thing on this one, I have x times the natural log of e plus c. So the natural log of e squared plus 2 equals 2 plus c. So all we have to do to solve for c is just subtract the 2. So this is kind of a gross c, but it's just the natural log of e squared plus 2 in parentheses minus 2. And there's nothing we can do to separate that natural log. Well, wait, hold on. We could do, what is that, the power property? So this would be e squared plus, or no, that's not right. Never mind, you can't do anything to that, I lied. So that's your c. So your particular equation is going to be x plus the natural log of e squared plus 2 minus 2. That was a tough one. Is that the only one like that? Yeah, let's make sure we do all those ones. Oh, okay, 13. 13 is not as gross as that one. This is one you should be able to do, number 13. Okay, so first we dx it. So we have dy equals 3x squared y dx. Okay, so now you got to get the y to the other side. So how are you going to get the y to the other side? Divide by it. So I'm going to call this 1 over y dy equals 3x squared. Oh, actually, this is grosser than I thought it was. Whoops, no, sorry, my bad. Getting ahead of myself. Dx. Okay, now what? Integrate it, good. So the integral of 1 over y is?
Why can't you just do it?
Because you have to divide by the y. So if you divide by the y, I'm going to make it look like 1 over y because it'll be easier.
What's the natural?
Nice, good. The natural log of y. And then what's the integral of 3x squared? Divide by it. Good. Can I just call it x cubed? Plus c. Okay. So on this one, how do you get rid of a natural log? With an e. So to get rid of an e, we multiply by a natural log. But to get rid of a natural log, we're going to do an e to the. It's actually an exponential one to make this work. So you do e to the. And then that actually will cancel straight out because e to the natural log of y is just y. And then we have e to the x to the third plus c. Definitely requires a lot of natural log and e review. Alright, I think I'm going to let you guys finish this up. If you have questions, you can ask.